So anyway, some of these solutions, some of the things that we did to get this type of control, how do you go that last mile? Everything is the final mile. Getting to a degree, getting to a percent, not so hard. Getting to 0.5% or 1/10 of a degree is tough. So with this, we recirculate the air a little bit. It makes, from an energy efficiency standpoint, this is a win. For a laser lab where you don't have a whole lot of dangerous chemistry going on, it's safe. We can make sure that it's zoned properly. It lets you wring out the water to get humidity control. They're relatively simple solutions to this. Putting a PID loop on your heating and cooling coils to make sure that you know the temperature of your coil, not merely the temperature of your water. So you might, if you want to run a 70-degree lab, thank you. If you want to run a 70-degree lab, you may well want to run an 81-degree cooling coil. And if you turn something off, you might need to move it to 80.2. And having that PID loop that controls the coil very accurately is extremely good. It divorces you from the changes in your steam plant or small changes from 150 to 155 degree water. You don't really care. It works out very, very well. And then you have to deal with the controls, which of course are more complex, but with separation of time scale, it works out fairly well. Understanding how to monitor these things. This is also important. Making sure that you're watching the lab in the right place, which is typically right above the laser table. That's important. Making sure the bottom skin of the laser table is the same as the top skin of the laser table so the whole thing doesn't bend. I mean, yeah, sure, it's 3 tons of steel and it's 18 inches thick, but it doesn't take much for this thing to warp or stress or show torsional strain, and that'll also ruin your experiment. So there are a lot of these types of things where they really help. Where in the lab do you put the laser table? How do you make this like an air curtain? How do you ensure that you are as stable as possible at the laser table while maintaining a clean environment? Do you push the air down on the table, or do you push it down on the sides and suck it up over the table? What's the right way to do this? So there were a lot of airflow considerations. There were a lot of issues with resonance to make sure your ducts aren't going to vibrate, because you can hear things down to about 30, 40 hertz, but my table resonates at 10 hertz in one direction and about 2 hertz in the other. And so any little bit of rumbling will affect these types of... So any little change is going to affect the performance of this system. And then also there's sort of other aspects that I never thought about when you're running a lab, which is being nice to your neighbors, making sure that you're not, or that they're nice to you, sucking things in from neighboring rooms or blowing your air out into neighboring spaces. Thinking about the noise from your air handlers and where you actually put these things. I mean, when you go into a chemistry lab, there are a lot of things you worry about, most of which involve safety or actually getting the work done, but you don't think about where is the air handler for this space. You don't think about, is it vibrating above my table or not. So figuring out where to put these, how to use office spaces and neighboring labs as ante-rooms and airlocks, understanding the pressure schemes and how we're going to monitor those down the road. A lot of that came in, and I just never thought about this. And then little things, just balancing the different ducts to make sure that you don't have the same airflow everywhere and you get slightly different resonances. And that can go from how you hang them, to how you size them, to how much linear velocity you put through the different ducts. So there are a lot of neat sort of things that went into that, all of which worked, which is why I'm here to tell you about it. And then if you look at the lab, this is what it looks like. So this is what happens when I ask my students to step out of my photo. Normally they're in there. But you can see many aspects up at the top. You can see some of the supplies around the edges. You can see that perforated return above the laser table. That's what that 6-ton laser table looks like floating on a bed of air. So if you walk up to it and you push on it, the whole thing kind of floats and jiggles. So it's 3 tons, but just floating there. And then you've got $1.5 million of equipment sitting on the top. You also have all your chillers and heat-producing appliances in a separate air-conditioned, soundproof space. Also where you can lock your students if they misbehave.